Hi everybody, I'm Brianna Wendt. This is a quick video summarizing my final project for CSCI E-7 Introduction to Python. So my project, the objective of my project was to create a program that takes a user's location data to determine which airplanes are flying overhead and provide information on that flight. Ultimately, the vision for me was that it would be an app on your phone that you would open, click what airplanes are above me, and you'd get instant data. Because the inspiration, as I say here, is that, I frequently will stop and look up and wonder, what that airplane is that's overhead. And there's tons of flight tracking software and programs and websites out there, but the problem with them is you have to kind of zoom in on the map and find a flight, and then by the time you've figured out which airplane it is, that airplane's already gone. So the vision for me was using a user's location data to be able to say which airplane is overhead and give you information about that. So obviously that's a little bit out of the scope of this class. So this is kind of my first steps towards that ultimate goal. And one of the big challenges that I ran into right away with this project is that a lot of the flight data websites either don't allow web scraping because you have to be someone who's paying for a subscription to those flight data websites for a reason, or a lot of the websites have all of the live tracking data kind of embedded in JavaScript objects. So I spent a lot of time figuring out how to scrape from JavaScript. So you'll see a bunch of that in the program, but that was definitely the biggest challenge for me with this project. So let me walk through this. So I attempted to use Beautiful Soup where I could, and for a couple things I was able to use just the basic Beautiful Soup HTML scraping. So that's what I do here. So what I'm going to do, because I'm not actually using location data, I'm just going to go to FlightAware and look at the map here. I live in the Seattle area, and I'm going to select a large incoming commercial flight. Let's see, let's do $2523. Okay, so I'm going to click that. But so how I have this set up is that when I run this first block, I input the flight. Normally this would be using the GPS data that I mentioned, but for the purposes of this, I'm going to manually input which flight I'm looking for. So then, looking at all the tags on the website, this is just a slice of all of the HTML tags, but what I noticed immediately was that the tags that I was looking for, I was not seeing. So if I was using Beautiful Soup, this would be how I would look for the track log link, which is where all of the detailed location data is, but obviously that is not a possibility because all of that information is within a JavaScript object. So this is my first JavaScript block, and what this one is doing is I'm actually creating two different elements, one for later on, but this first one is going into another web page essentially that has all of the location specific data. So I find the element that has this ID, and then I create a new link, basically. The other one is for later on, and I'll talk about it at that point. But these items, these are web drivers that I am importing from the library Selenium, and I'm also using Phantom.js to scrape the JavaScript. And they take a bit of time, each one. I think I have two web drivers in here, and then they create web elements. So that one's done. now we can see that when I run this, this new link has been created for tracking this flight, which I inputted, and getting that location data. So I'm not using true GPS data, so this is just an artificial example. This is latitude and longitude nearby. So then within that website that I just redirected to, I create another driver that's going to pull elements from a table of latitude and longitudes. That will take a minute as well. And because they're not iterable web elements, I have to kind of go through them in this way and pull the text out that I'm looking for. So that's what this does. And I'm pulling out the most recent latitude and longitude that's been updated on the website. So then here I compare my location with the plane's location. And if the latitude and longitude are within 1, I'm going to say that that plane is overhead. And you'll see here it says this flight is not overhead. So I will have to think about later on as I work on this program more, what is a feasible kind of sight distance for latitude and longitude. This one is not close enough for me to see it yet. So here I'm using the beautiful soup instead of the JavaScript web elements that I scraped to grab some data that was available, and I am printing that out to the user. So you're tracking this flight coming from here to here, the airline abbreviation, the aircraft, the origin and destination airports. So that's all I could kind of derive just from using beautiful soup. So then going back to the driver, the web element that I created earlier, I'm going to get some more information. So like I said before, because those are web elements, I have to kind of pull out all of the information. So here I'm creating a dictionary that has more of that information, more of those details here. So you can see the flight departed from Seoul. It's headed to Atlanta, so it's flying kind of over the Seattle area on its way to Atlanta, which is pretty cool. You can see that it departed 21 minutes early, and it's arriving at 10:30 p.m. Eastern Time tonight, and it's on time. So kind of as I mentioned, some next steps for this project is that I need to think about what a suitable visibility range is for latitude and longitude. And obviously there are tons of factors that will play into that. You know, actual visibility, cloudiness, if you live in a city and you're in an urban canyon, there's all sorts of factors. So I would need to calculate kind of what the eye's distance can see in latitude and longitude. But 1 seemed like a reasonable starting point because 1 latitude and longitude unit is about 69 miles. And then the next step would be that I need to, aside from thinking about programming this into an app interface, that I would need to utilize the user's GPS data, get access from a user, and then pull their latitude and longitude to compare it to the airplanes around. So that is the summary of my final project for this class. I am looking forward to developing it further. This is an idea I've had for a while. So, okay, thank you.